Hey, good morning, good afternoon, everybody. Welcome to our June 2018 TBC Power Hour. Today we'll be talking about going vertical in TBC. How we're going to do that is with the new projected surfaces added in TBC version 4.10. My name is Joe Blecka. I'm the TBC product manager. I'm based here in Westminster, Colorado, and there is my contact email address. Please send all of your love/hate mail about TBC to me. Be happy to respond and address your concerns or take your compliments or suggestions. Thankfully, I will not be talking for most of this. Mr. David Delgado is here with us. He's prepared this presentation, and without much further ado, I'll hand it over to David and take it away, man.
All right, thanks, Joe. So my name is David Delgado. I'm a product applications engineer, also here in Westminster, Colorado. I've been on a rotation with the geospatial office software team, and I've been supporting the project with a few others since my time has started here. And so I'll just get started. So first, I'm going to give you an introduction to projected surfaces. What is it? Why is it important? That sort of thing. How can you use it? And then show you with a workflow demo all the way from start to finish, from messing around with the point cloud data to producing a deliverable. And then we'll do a short summary, and then Q&A and resources are next steps.
Yeah, and along the lines of Q&A, if you've got any questions that pop up, please type them into the chat window. We'll get to them as they fit into David's presentation, or come back at the end and get them. Or if it's something that we have to take outside of this presentation, we'll follow back up with you.
Okay. So first, the introduction. So this is an example of a 2.5D surface, or some of you may refer to them as a traditional surface. This was a surface created from point cloud data that we took of a cliffside on a beach. And you can see where the poor triangulation occurs, and that's due to the surface not being able to properly form the mesh over points that are right on top of each other with respect to the surface normal, which is the up direction in this case. So with projected surfaces, you're able to change that direction, or the normal axis of your surface. So you can change the direction that the mesh is applied over the points. So this is the same set of scan data and the same cliff and beach, only we used a projected surface to create the mesh, and you can see that the triangulation is much better around the cliffside. So this is kind of what motivated us initially to create this functionality in TBC, was that we had all of these sets of scan data coming in, and people wanted to create deliverables from them, but we just couldn't do it with traditional surfaces, or we had to do these very convoluted workarounds, which some of you may have had to do if you absolutely needed to work with vertical surfaces beforehand. So right now, or before 4.10, we only had surfaces in 2.5D, but now we can work with any surface and any orientation. And the value added there is you can now report volumes in any orientation. So if you're taking out material from a surface that was otherwise not measurable before. Also, change detection is a big deal, especially for us here in Colorado. I know a handful of customers that monitor a lot of cliff sides up in the mountains. So there's applications there. And then now with the SX10 and scanning support, we can take the photos and overlay them onto the deliverables to really create something that's pretty powerful to present to stakeholders. And also it helps with your office analysis process and reporting. And this all ties back into our main message, which is TBC is a field to finish with confidence software. And now with this added functionality, we reinforce that message. So some of the use cases, as I've mentioned, are topographic mapping, mining, building construction, heavy civil construction, tunneling, and infrastructure. So these are just 6 applications that we've sort of gathered with research beforehand, but we know that after releasing a feature, typically the users will determine how it's used. So these are just some sort of starting off points to sort of get you thinking about how you might be able to use the feature. And in the workflow demo, I'll show you one example of how a customer has already thought about using the feature. So, and with that, I'm going to switch over to the workflow demo.
David, what versions of TBC will you be working in today?
So right now I'm working in TBC 410. So just with the advanced module with scanning.
Perfect.
So I'm just going to switch over to my project. All right. So what you're looking at here is a set of scan data that we got from a customer in Denver. This was taken by a survey company that actually used an SX10. Unfortunately, they didn't use any of the photos with the scan data. They just used the scanning function. So what they did was they scanned this area twice because they're monitoring this wall. And I'll zoom in a little so you can see it better. So this wall right here, they're actually doing some excavation work underneath of it. And they wanted to make sure that the wall wasn't moving. So what they did was they scanned it once before the excavation began, and then they scanned it again post-excavation to see if there's any changes taking place. And how they actually checked was creating surfaces from the wall, and I'm going to show you that. So before you begin any analysis, you want to make sure that your scan data is properly georeferenced and set up correctly. So in this case, they used the same station setup to make sure that the scans were taken from the same location and were properly georeferenced. That is critical. Your analysis is only going to be as accurate as your station setup. So once you have your point cloud data imported, you can see here on the left-hand side in the View Filter Manager, we have an initial building scan, which is pre-excavation, and then a monitoring scan, which is post-excavation. So if I turn the monitoring scan on, you can see some extra points fill in, but otherwise it's right on top of each other. So I'm going to turn the monitoring scan off now, and I'm also going to turn off any excess points that we don't need. So I've already created a region beforehand just to save some time of just the wall that we're trying to monitor. So the first thing you would do is go into the Surfaces tab. And then we have the projected subgroup here with the Create Projected Surface command. So this is how we're actually going to create that surface. And just to make it so that we can keep track of everything, we should name it something intuitive. So initial for the initial surface, and then we can just change the color to distinguish it from the other surface that we're going to create. And then we can just select the entire area. And so the next piece is the plane definition. So the plane definition is also probably the second most critical piece when creating projected surfaces. This redefines the surface normal or the axis of the surface. So earlier I mentioned that the 2.5D surface is restricted by the up direction, right? So the normal direction of the surface is always going to be pointing up into the sky. Well, with projected surfaces and the plane definition manager, you can change sort of what that direction of up is. So you can redefine that here in the plane definition manager. So you'll see in a second, once I create the plane, it'll be a little more clear. So there's all these different options to redefine where your axis is pointing. So depending on the application, you might want to use one of these different options. So if we had maybe a surface that was a little more sloped, you could create a surface using 3 points by simply clicking 3 points. So I'll just do it here really quick to show you.
And notice how when David's clicking on the point cloud, it's an X, Y, and Z value that gets populated in the point dialog.
So using this 3 points option, the points automatically filled in. So now you can see the 3 axes that we created. So this almost see-through yellow plane that popped up is sort of like the ground in a normal situation, right? So if we just flip this over horizontally, the red axis is now the new up direction. So that's how the surface is going to be applied. So now all these points that are on top of each other, if we look at it normally, they're going to be flat on the ground, so to speak. And so for this option, we're going to go actually with the vertical plane. It's just a little bit simpler, and it's just 2 points. So we just click 1 point on one side of the wall and another point on the other, and a vertical plane is placed through those 2 points. And now we can just rename the plane definition. And we can hit close. And then we can hit OK. And so now the surface is being created, and it's going to look and behave as any other normal surface afterwards. And also, depending on your scan density and your project settings, it might take a little longer for your surface to create. There we go.
Get a question from Harry.
Yep.
What effect does locking your plane have in the plane definition manager?
So locking your plane means that it can't be changed. So you can't mess up the plane at all. You can't redefine it.
So it's just kind of a toggle to prevent you from locking it that can be unchecked or checked at any time.
Right. So it's just a means to keep it from being modified.
Great. Thank you.
Yep. So once I turn off the scan, you can see the created surface. And normally this would be just a mess of bad triangles because all these points are right on top of each other. But now you can see it's pretty well defined. And you're going to notice there might be some flags on the surface. Typically those flags represent points that are right on top of each other, and these can still occur even if you tried your best to make that plane definition work with your vertical surface. But sometimes there's still a few points in there that could just be from triangulation error or just error from your scanning instrument or something like that that can create flags. And typically they're not a big deal unless whenever you do your analysis you notice something strange going on, but typically we haven't had any problems with them. So you might also notice that there's a bunch of other areas on the surface that didn't triangulate so well. I think it's because we had a fence that was right in front of the wall, so that's why it's a little messy down here. So we're going to actually take care of that in a second using surface boundaries. So what you can do to clean up your projected surface is you can go to the point clouds tab, and then you can click on the cutting view command, cutting plane view, sorry, in the view subgroup. And so what this just did was open up another view that is from the perspective of your plane definition. So we called it wall monitoring, and there it is. Now we can see our surface, and it's parallel to this plane definition that we created. And so what we can do now is create a CAD object to define the boundary of our surface. So if we want to crop out any of the messy triangles in the bottom half of this surface, we can do that. So we're just going to name it boundary. And now I'm just going to mark the CAD object. Oops, got a little messed up there.
And David, your boundary for a projected surface object, does that, you're drawing it in the cutting plane view on the same plane definition that is required, correct?
Yes, so you need, in order for the surface boundary to be applied to the correct surface, it needs to be in the matching plane definition. So right now, it doesn't really seem like a big deal, but imagine if you're working with a more complex project and you have a bunch of different surfaces at different angles and orientations, and you maybe will have multiple projected surfaces using different plane definitions. So in order to make sure that the boundary is applied to the right surface, we make sure that you match that to your plane definition. So now that we have the CAD object defined, we can go back into the Surfaces tab, and we can click on the Surface Boundaries command in the Edit subgroup. So you'll notice in the Surface dialog, the initial surface is automatically filled in. And just to make sure we're just selecting the CAD object, you select the rectangle you just created, and you just hit Add. So this is going to crop out everything outside of the rectangle and hopefully give our surface a little more of a clean look. And almost done. And also keep in mind, whenever you're adding and deleting some of these CAD objects from your surface boundaries, your surface has to recreate each time. So if you added a surface boundary and you select everything in your project and you delete that, the surfaces have to re-triangulate each time. So just keep that in mind if you're working with a lot of surfaces and boundaries. So now you can see we have this nice rectangular surface, and we can actually go ahead and get out of this cutting plane view for now. So here we are, and I'm just going to take out those flags, not really using them right now. Great. So now at this point, we have to do the same exact process for the other monitoring scan. So we can turn off this surface, and then we can turn on the monitoring scan. So this is the scan data from the second scan. So like I said, the post-excavation scan. So we're going to do the same exact thing, and I'm going to go just a little quicker just because you've seen it. So once again, select all the points, create projected surface, name it monitoring, change the color if you want, and then those are the members that I selected. And then once again, very important, make sure you have the same plane definition. You can't compare surfaces with different plane definitions. It's sort of like if you were trying to compare 2 point clouds that aren't georeferenced to the same spot. Their geometry and their measurements are directly tied to that plane definition. So now we can hit OK, and a surface should create. And then after that, we'll go through the same process of just applying that CAD object to the surface.
We got an interesting question here for geological purposes.
Mm-hmm.
The question was, can you use this application for analysis of the composition of the Earth, or recognize cracks in the face of open mining operations. So you'd be able to do what David is doing now, creating multiple projected surfaces and creating a cut fill map to compare one surface to the other, which will in turn then illustrate any cracking differences between the two scans, or cracks will also show in the triangulation of the projected surface object model, just like they would in any XY plane based surface.
So if I've heard you correctly, you're asking if you can use this to monitor cracks or just identify cracks?
Yeah.
Okay. So you can, but just keep in mind that if those cracks, from the perspective of your plane definition, they may form, they may poorly triangulate if they're sort of vertical with respect to that plane definition axis. So you still have to be careful with that. I would say, at least in the experience I've had with them so far, that it might be recommended that you just use them mainly for maybe detection at most. For something like that, you might have to use another process simply because you might have poor triangulation within the crack. But it's kind of hard to say and without knowing exactly what you're doing.
Sure.
But yeah, you can definitely use this to detect any changes, like if anything has been removed from the side of a wall in a mining operation. I hope that kind of answers your question.
Yeah, thank you.
Okay, so we have our second surface now, and we can turn off our scans so we can see it. This one looks pretty much the exact same. So we're going to do the same thing. We're just going to take the rectangular CAD object that we created, and we're going to apply it. And the reason why we're even doing this, besides just cleaning up the surface, is also to make sure that the surfaces that we're comparing are just right on top of each other. This might matter in some applications. It might not matter to you, depending. But we just wanted to make sure that you're aware that you can do this in case you did only want to monitor a very precise geometric location. So we can do the same thing now. We can go back up into the Surfaces tab in the Edit subgroup and click the Surface Boundaries command. And we make sure that we're applying it to the right surface, and we can hit Add. Oops, let me just make sure that the surface boundary is selected. Add. So the same thing, it's just essentially recreating the surface.
Chris asks, while we got some time, can you edit the created surface to remove troublesome flags?
Yeah, so you can still edit the surface just like you would any other 2.5D surface. So if you have some flags that were created because you have some points on top of each other, you can actually, I think you can actually go back and edit the point cloud, and it should retriangulate your surface. So if you see like a flag and you zoom into the location, like for example, if we zoom in here and you're looking at it and maybe there's a flag in this little pocket here in the wall, you could go back into the point cloud, maybe delete a single point that might be causing the flag, because that's usually what's happening. It's usually a couple of stray points. And then you can recreate your surface, and then it should keep the same boundary, assuming you haven't removed it.
Yeah, and if you use the keep in, keep out functionality, or create a new different region, and then depending on the surface properties you have set for your projected surface, if you have it to auto rebuild, the surface will update automatically, just like David said, how the XY plane traditional surfaces are edited or updated with point cloud as the surface member in those XY plane surfaces.
Right.
David?
Yep. So now that we have our second surface here, we can now compare the two. So how we're going to do this is just with a traditional cut fill map. So now if we look back up into the Surfaces tab and go to the Create subgroup, you'll see the Cut Fill Map command. So the reason you might be wanting to use the Cut Fill Map command is that if you wanted to show any movement between the two surfaces. So in this case, the customer wanted to see if the monitoring scan or the monitoring surface had moved either forward or back from the initial wall. So just like a regular cut fill map that you're creating, we can give it a name. And for the initial surface, we'll click initial, and then final, we'll choose monitoring. And really, it doesn't matter too much in this case. You'll still be able to create the surface even if you flip the. Make sure you note which one is initial and final, because that'll change the coloring and the whether or not it's cut or fill. So I'm actually going to put this in a new layer, just because sometimes these cut fill maps, whenever you're doing change detection, can take up a lot of processing power, just because if you're comparing two surfaces that are right next to each other, and you're looking at maybe movement on the order of millimeters or even centimeters, what gets created is called a daylight line, and that shows where the surfaces are intersecting. So if you have these two surfaces that are right next to each other, and since I've gone through this before, I know that they're almost right on top of each other, TBC will create all of these lines on the surface, and that takes up a lot of processing power. So if you notice that your cut fill creation is taking a long time, or your TBC just slows down drastically after creating a cut fill map, I'll show you in a second where you can actually change that in your project settings after you create the surface. So we're just going to go and create a new textile here. So this is just the textile manager, same as always. You can just change the height to make sure that the labels on the grid of your cut fill map are readable for whatever you're trying to create. So I'm just going to lower them a bit. And then I'm going to change my grid spacing to about 3/4 of a meter, and we're working in metric here. And I'm actually not going to create it within this project just because it will take a while. So I've actually got another project with the surface already created, just for the sake of time and not boring you all with watching it process. So this is something that you would get whenever you hit OK and the cut fill map is created. So if you notice, here's the grid. There's all your cut fill marks. If you look at those units, we're talking about movement on the order of millimeters here. So that's why I mentioned earlier to make sure that to check your project settings and your surface settings if something seems like it's going pretty slow. So to give you an example, I'm just going to show you the properties of the surface. So right here, display daylight line. Sometimes if you turn that on and the surfaces are really close together, you'll see how much slower it'll be whenever you're just trying to move around in TBC. So I turn that off for now. And then here you can see the surface rebuild method. And so this should all look identical to a traditional surface, 2.5D surface. The only difference now is the UCS, max and min elevation. So these numbers are now with respect to your plane definition that you created. So the UCS is just another way of saying the new coordinate system that you created from the plane definition. Let's try to show, oops. So this is just the cut fill map, but hold on, let me actually pull up the surfaces here so you can see the normals. So I've now opened up the properties for my initial surface just to kind of show you more what I'm talking about here. So if you scroll down to the bottom of your projected surface in the properties pane, you'll see the projection orientation and a normal definition. So this normal vector here is the normal axis of your surface. So if you're trying to compare two surfaces, they need to have the same normal with the same signs and everything. So even if they have different names for their plane definition, if they have the same normal, you can compare them because, like I said, they'll just tied to the math behind the surface. So now you're probably thinking, okay, I have this cut fill map. What can I do with it? So what we're going to do now is show you that the projected surfaces command is also supported with drafting and DynaViews. So if we go to the drafting tab here, and we go to the sheet subgroup, and we click on drafting templates, it's going to pull up a lot of the Trimble predefined drafting templates that we've given you. And so just for this project, we're going to use a preset drafting template. You, of course, can use any drafting template that you've made yourself or somebody else has made. So I'm just going to use this feet arch D 24 by 36, and I'm just going to drag and drop. Okay, and now you can see in the Project Explorer, under Plan Sets, you can see the drafting template that we just loaded. So now we're going to put this projected surface into a plan sheet. So we're going to go to a new sheet view. And so I don't know if you've used DynaViews before, but essentially what you can do is create a window from your drafting template or your drafting sheet onto anything that you want within your environment. So if you create a boundary for your projected surface and you want to display what's inside that boundary, you can use a DynaView. So I'm just going to make sure that my surface boundary is turned on so I can select it whenever I'm creating my DynaView. And so if I go into the drafting tab, into the DynaView subgroup, and click Create DynaView, I can name it Dyna. And now I can choose my frame. And so the frame is just going to be that, that surface boundary. And for more information on drafting and DynaViews, we have, I think we have some tutorials online and a lot of other literature that you can look at.
Oh, yes.
So I'm just going to change the scale here. That'd be pretty small. So now you can see that's the outline of the projected surface that we just down a little more. Make it as big as possible. Looks about good. There it is. Okay, so yeah, now you can see the projected surface with the grid labels and all your cut and fill values here. So if you wanted to, you can create a whole sheet set out of these, depending on your project, and you can add your company logo and everything else you can do with drafting. And I think we even supported the scale bar if we specify the cut fill map here. Yeah, we do. So now we can place our scale bar, you can add labels, everything like that. So this is just one of the deliverables that you can create. You can still use DynaViews with just the projected surface. Yeah. So if you wanted to share this with somebody, we have Trimble Clarity integrated with TBC. So if you wanted to maybe share your creation, your deliverable with any project stakeholders or clients, or even just for visualization at your office, if you're just trying to show somebody on your team the project you're working on. So what Clarity is, it's a web-based or a browser-based collaboration tool where you can post station views, and whatever you show in your station view is determined by what data that you've brought in. So if you have data from an SX10 with point cloud and images and maybe GNSS data, you can publish all of that online so that anybody can see it. So I'm just going to show you Trimble Clarity. And so I've actually, I already have another project uploaded to Trimble Clarity for the sake of this demo. And the reason why I did that is just because it could take a while with the projected surfaces and the triangles and everything like that. But what you would do is you would go up into the Home tab and you would hit the Publish to Clarity option here. And so this is where you would sign in with your Connect profile and you would choose a station view. But because the client that collected this survey data didn't have any station views, we can't publish anything from this project.
David, do you have the data, the TBC project open that you're going to show here?
Yes.
Okay.
Yeah, so I already have the other project already open up in Trimble Clarity.
But you have it open in TBC?
I do not have it open right now.
That's fine.
So if we go up into the web browser, this is something that you can publish with Trimble Clarity. So this was data that we collected from a Trimble S7 total station. Oops. So this had images also combined with it. So with an SX10, you can do the same thing. So you can publish this view from the station. So if I just drag this up a little, you can see down here in the bottom half of the map, the station that I published. And if you have multiple stations, you can actually jump between them. But for this project, we only had one. And we did the same exact process. We scanned this dam and we scanned it twice and then created a cut fill map out of it. And then we displayed that along with the image data and published that to Clarity. So anybody with this link, so you know, if you want to share that, it doesn't have to be private, can view this exact same view in their web browser, and it's browser agnostic, and it doesn't rely on any software or anything like that. And you can make measurements and annotations here as well. So that concludes the workflow demo. And so what we've basically shown you is everything from start to finish with projected surfaces. We've shown you how to create your projected surfaces and why it's important, and how you can actually edit them and make sure that your analysis is correct. So like I've said before, these are just a few deliverables that you can create with projected surfaces. These don't have to be the only things you can do. So we'd love to see what you can do with projected surfaces if you have different applications. I know that we've had other customers already coming to us asking, you know, hey, can I add a vertical alignment to projected surface? Can I use projected surfaces to you know, draw the line work on the bottom of girders? So there's a lot of other things out there that we we haven't specifically designed projected surfaces for, but we know that it's out there.
Okay. Well, thank you, David. I've got a couple of poll questions here, and as we put in the poll questions up, we can talk about some of the questions that have come in that I haven't been able to answer. So let me launch this poll question. If you can give us your feedback on using projected surfaces in TBC 410. Are you using them? Are you not using them? Has this webinar sparked your interest, and you will start looking for applications, or you will after learning about them today? Leave it open for another 30 seconds or so. One thing, two of the questions that have come in have been regarding the plane definition and how you to define it for the application. So the plane definition is, by definition, a plane. So in the questions of spherical or rounded surfaces or applications, there's several different methods and approaches to define your plane. We're still dealing with a two-dimensional plane that has a different orientation. So with applications for spherical or rounded or tunnel applications, there may be a need to come up with more than one plane. You may have a need to define a plane that isn't necessarily perfectly aligned, but is more of a best fit to your data. So it can be a little bit of an iterative or learning process to describe non-planar geometry with planes. And obviously, every situation is different on a case-by-case basis. I'll close that plane, thank you. Or excuse me, close that poll, thank you. And then I want to launch another one just to verify the workflows that we have originally set up and targeted for. What applications are you or would you use projected surfaces for? These are the big five that we've really targeted and wanted to see how we can continue to refine our message and documentation, tutorials around the projected surface object, and potentially where we need to go in future development projected surfaces 2.0. Question on Clarity from Brett. David, does the Clarity product have the ability to control who can view it as opposed to just anyone?
Right. So that's sort of up to you when you share the link. You can determine who you send the link to. I'm not sure. I don't think we support currently having the same link with multiple viewing options within the same link. But you can change what the link allows the person to do. So if they want to, if you only want them to be able to make annotations as opposed to also making measurements, you can change that.
Yeah, so there is a little bit of user settings and accessibility. You can make the link so only the people that you send it to can view it, that they cannot share it, outside of your organization, for example, if it is data sensitive. So there is a level of permission set up within Trimble Clarity. Something to note as well, and we saw it on the publish to Clarity command, this is based off of the Trimble ID account. So if you're a longtime Trimble user, we've gone through iterations of having you sign up with different accounts and different platforms. Trimble Clarity is based off of Trimble Connect as sort of an application of Trimble Connect that uses the single Trimble ID. So we are trying to streamline the accounts that you have and what the Trimble ID can authorize you for. You'll see there's other applications coming and already existing in TBC based off of the Trimble ID. Well, thank you for your poll responses. We'll get back to some questions here. Application question for Mark, from Mark, regarding deformation analysis. This tool was set up in a very much geospatial context. So coming off of known control and using your total station and theoretically a tight station setup or a resection, and then being able to monitor wall deformations, for example, settlement of that first example that David showed. This doesn't replace a formal monitoring program, something that Trimble's T4D system would offer, but this is sort of maybe a pre-monitoring or a monitoring on a geospatial survey scale. So applications for structural monitoring, initial structural monitoring, that dam that David showed there in Trimble Clarity, things like that. This doesn't replace a formal monitoring program or deformation analysis program.
Send that.
All right, a question came up here internally that we were going to share the Trimble Clarity link with you. That's something that we can do so you can take a look. You don't necessarily have to have a Trimble ID to view the link. So, the Clarity product is marketed for your customers' customers or your customers' customers' clients or somebody who, not geospatial minded, not geospatial expert, maybe never even heard of Trimble, doesn't care who Trimble is. Just want something that works that they can visualize their project data for, and happy to share that project with you. You'll notice in Clarity, the surface used is inclined, and then it goes vertical. That was with one projected surface object, where in the past you couldn't go vertical at all, with the XY plane projection, and you'd have to have multiple surfaces even to approximate that. All right. There's a couple of more questions here. Wang asks how to create a plane based on lines.
Yeah, so there's a plane definition option, which is to create from an object. So if you have a closed CAD object, you can select that option, but it also depends on the geometry of the object, if it's closed, that sort of thing. So yes, you can create it from an object.
Yeah, now it's in the plane definition manager. All right. Please send your questions in. If there's anything that we are unable to get to in this session, we've got your email. We can contact you here offline. Got a couple of quick resource slides to share with you now. And in addition, that's where I was going with the Clarity link. This presentation will be made available. The slides will be, and the data as well. So when you get the notification that this recording is available, you'll also see the data and presentation, and now the Clarity link as well. All right, so hopefully we've spawned some interest here on TBC. If you're new to TBC, welcome. And if you're new to projected surfaces, also welcome. Thank you. We've got our new-ish TBC webpage, trimble.com/TBC, really focusing on making more of our resources, more of what the team here does every day, more accessible to you, our customers, and our end users. We've got customer success stories there, TBC overview video. If you are new to TBC, it's a pretty slick 2-minute long overview on everything that TBC can do. Our YouTube channel is probably the best source for introduction to new features. David has put together 4 videos on the projected surfaces. There is a projected surfaces video playlist that you can review. And now, listening to this Power Hour, you be able to work with the data yourselves in TBC 410 and higher. Power Hour archives, every one of these since back in 2015 when we started them are available for download and review at your own schedule. These wealth of knowledge for you to review at any time for free. Using our TBC community page, a public forum to get and connect with us. We highly recommend checking out our TBC Tip of the Week page. We've got many different tips there. We are batting 1,000 for 2018. A new tip every week. I think we're up into the mid-40s. So lots of little tips and tricks and Easter eggs, if you will, about TBC there. All right, next steps from here. We encourage you to download TBC. The latest version is version 4.10, available from trimble.com/TBC. You can get a free 30-day demo license of all of the functionality from your local Trimble distribution partner. Mapped there, you can see we are available. We are where you are if you're looking to get a TBC demo license. And then next Power Hour in July, hot off the presses, we will be talking about the latest TBC cadastral workflows and a lot of the functionality that has been added in TBC version 4.10, rounding out our message that TBC is for surveyors, by surveyors. If you haven't been keeping up with what we've been doing on the cadastral space over the past couple releases, this is the webinar for you. We've got Matt McLean signed up, whether he knows it or not at this point, probably with myself or Boris to guest host with him. And we've got a lot of good new TBC information to present to you in a couple of weeks. All right, so with that, I think I'm done. David, do you have anything else?
Yeah, so just to remind you that if you have any more like technical questions or you're interested in projected surfaces, feel free to post them on the community page. Like we said, we post a tip of the week, and there's even a projected surfaces tip of the week specifically that I posted that goes over into a lot more detail about how projected surfaces are created and why you can compare certain projected surfaces to each other and why not.
Great. Well, thank you. Thank you to TBC's Marcom team for setting this up, and really appreciate the work you put in on this. And if you got any more questions, please let us know. And if not, we'll see you in a couple weeks to go over the latest and greatest TBC cadastral workflows. Thanks, everyone. Have a good day or have a good evening wherever you are. Take care.